Question number 41. Consider the following statements about NaCl. Assume Na represents the Avogadro number. So in the first statement, we have been told that the number of second nearest neighbors of Cl minus ion present at corner is 12 in the NaCl structure. So the examiner seems to be interested in the second nearest neighbor. So if we talk about the Cl minus present at corner, the nearest neighbor will be at the edge center. So those will be 6 in number. If you talk about the next nearest neighbor, so the next nearest neighbor will be the atom present at the face center of which the corner is a part. So there are 12 face centers. So students, this statement is correct. If you look at the second statement now, 1 gram of solid NaCl contains Na by 234 unit cells. So if we talk about 1 unit cell, so we know that 1 unit cell contains 4 formula units. So if you talk about the mass in 1 unit cell, it is going to be 4 into 58.5 upon Avogadro number of grams. So this will give us a value of 234 by Na grams. So we can see that since 1 unit cell contains 234 by Na grams, so 1 gram will be contained in Na upon 234 unit cells. Okay. Students, the second statement is also correct. If you look at the third option now, Na unit cells are dissolved in 1 liter of water to form NaCl solution, which has a vapor pressure less than 1 atm at 373 Kelvin. So students, this statement is also correct. Due to the addition of solute, the vapor pressure of water decreases, and as such, the solution will not boil at the boiling point of water. So the third statement is also correct. If you look at the fourth statement now, in solid state, NaCl contains Na plus and Cl minus ion, and it is good conductor of electricity. Students, this statement is incorrect. In the solid state, the ionic solids are not conductors of electricity, as the ions are held in their place by the electrostatic forces of attraction. So the examiner seems to be interested in the number of correct statements, and out of the 4 statements, 3 are correct. Students, for this question, we have to mark option 2 as the correct answer. Let us look at the next question now. Question number 42. 1 mole of ferric oxalate is oxidized by X moles of potassium dichromate in acidic medium. The minimum value of X is. Students, if we talk about ferric oxalate, we have Fe in a state of 3 plus and we have C2O4 2 minus. So the formula will be Fe2 C2O4 whole thrice. So if you talk about the N factor will be equal to 6. The Fe will not get further oxidized. It is already present in plus 3. But if you talk about the oxalate ions, in the oxalate ions, the carbon is present in a state of plus 3 and it will be converted into CO2. It will be in a state of plus 4. So we have the N factor of oxalate ions equal to 6. We have 3 oxalate ions in the system. And we know that the N factor of potassium dichromate is also equal to 6. So we have Cr2O7 2 negative converting into Cr3 plus. So since the N factors are equal, the moles also have to be equal. So if we have 1 mole of ferric oxalate, we are going to need 1 mole of K2Cr2O7 as well. So students, the correct answer to question number 42 is option 2. Let us look at the next question now. Question number 43. Which of the following is not true about the S2O3 2 minus molecule? So the examiner seems to be interested in the structure of the thiosulfate anion. So we can draw the structure. So we have S double bond S, double bond O, single bond O negative, single bond O negative. So this represents the thiosulfate anion, which is the S2O3 2 minus. Now if you look at the options which are given to us, the examiner is interested in the statement which is not true. So first option says there is SS linkage. We can see that there is SS linkage present. If you look at statement 2 now, both the sulfur atoms are in different oxidation states. This is also correct, students. The environment around both the sulfur atoms are different. So they have to be in different oxidation states. If you look at the third statement now, both sulfur atoms are in plus 2 oxidation state. Students, this statement is incorrect. We've seen that the vicinity of these 2 sulfur atoms are different, so their oxidation state cannot be the same. If you look at the fourth statement now, one of the sulfur atom has no SO linkage, so this is correct. The sulfur indicated has no SO linkage. So out of the given statements, we can see that only the third statement is incorrect, and we have to select the third option as the correct answer to question number 43. Let us look at the next question. Question number 44. The plot of the radial probability distribution function P versus distance r of the electron from the nucleus for the 3p orbital is. So if we talk about the 3p orbital, we can talk about the radial nodes. Radial nodes is given by n minus l minus 1. So the n value is equal to 3. The l value is equal to 1. So the total number of radial nodes will come out to be equal to 1. Okay. So out of the given graphs, we can see that only the graphs indicated in 2 and 4 have one radial node. But if we talk about the probability of finding an electron at the nucleus for the 3p orbital, it is equal to 0. So out of the given graphs, only the second graph is correct. So we have to select option 2 as the correct answer to this question. Let us look at the next question. Question number 45. Among the bromides 1, 2, 3 given below, the order of their reactivity in the SN1 reaction is. So if we talk about the SN1 reaction, we know that carbocations are formed as intermediates in the SN1 reaction. So we can have the carbocations formed in all of these cases. So if we compare the stability of these carbocations, we can see that the third one is aromatic. The second one is anti-aromatic. Whereas the first one is allylic. So if we talk about the stability of these carbocations, we can see that the third is more stable than the first one, which is more stable than the second one. So the ease of SN1 reaction follows the stability of the carbocation which is formed. So students, for this question, we have to select the second option as the correct answer. Let us look at the next question now.